Good morning, everybody. Welcome to class this morning. Another great week, another CTS 217 online live stream. This week we'll be talking about Module 4 content material. Before we get into that, just a few quick announcements and reminders for you. One is that I've went ahead and graded your Module 3 assignments, so those are all in the gradebook now. Great job, everybody. By and large, excellent work. Really thorough in your assessment of all those help desk softwares. And I also like reading your discussions about, setting up your workspaces and all that sort of stuff as well. You all really put a lot of effort into that stuff. Really put a lot of effort into your assignments, I should say. All right, because it's more than stuff, right? Like, it's helping us learn and grow as human beings, right? So you guys have been really putting a lot of effort into those assignments, and you really, I'm one of the believers that you get out of it what you put into it, and I think, with all the effort that you all have been putting into it, hopefully you're getting a lot out of it as well. So those are graded, and they're in the grade book now. We're in the midst of Module 4 at this point, which is about troubleshooting. And essentially what your troubleshooting process would be. Now, we've got courses that are about specific troubleshooting things, right? Like, we have the hardware course and the advanced hardware course where you're actually doing troubleshooting, especially in that advanced hardware course, right? So this isn't a module about how we troubleshoot specific problems, so much as how we troubleshoot problems in general. Because especially when you're getting started in the IT field, troubleshooting is going to be, a part of everyday life. And you might have to troubleshoot a problem that you've seen a million times. You might have to troubleshoot a problem that you've never seen before in your life. So having a troubleshooting strategy for how we approach problems is just as important as being able to kind of know a solution, right? Because you're not always going to know the solution. So it is important for us to develop this sort of troubleshooting strategy, develop this basis for how we approach problems. And so really, like, when we look at it, like, that's kind of where the graphic of the course down there comes from. We have this street sign where we're kind of on the corner of problems and solutions here with our troubleshooting strategy. Essentially in IT, but really in any job that you could think of, right? Problems are going to arise. You're going to be faced with some kind of problem. And being able to understand the problem and take it through a process that can give you a solution for that problem is critical. So again, this is something that applies to jobs in IT, jobs in help desk, jobs in computer training, but we can also take this and expand it out. There's a high degree of likelihood that not all of you will be in IT careers forever, but you can still take these troubleshooting skills and you can expand them out to other types of jobs, other types of positions, at all levels, right? Like, it applies to management just as much as it applies to, like a tier 1 help desk support person. So it's pretty important that we kind of examine how we troubleshoot. So before we get into how we troubleshoot, I think it's a good thing to kind of just examine what troubleshooting is in general. When we're talking about troubleshooting, we're talking about a process of defining, diagnosing, and solving technology problems. And I think the key word here is process, right? We want something that we can kind of standardize as we're facing problems. Because it's like I said before, some problems will be known to us, which will allow us to move through this process quicker. Some problems will be unknown to us, which will present us more challenges as we're trying to go through this. But either way, if we follow a process, if we set out a step-by-step sort of situation here, where we are following a process from beginning to end, then we're going to have an easier time coming up with solutions for our problems, because we have our starting point, we have what we're going to do, and we have our end point. And so, moreover, when we're thinking about troubleshooting, we're also thinking about these different sorts of thought processes and communication skills that we have to use. Right? So you have this breadth of knowledge that is a combination of your personal experience, right? We've mentioned that before. Your personal experience is the combination of everything you know and everything you've done. So you have this breadth of knowledge that includes your personal experience, your ability to communicate, right? Because one of the things we were talking about last week was being able to work with your coworkers on problems, and the proximity to being able to collaborate in your workspace. So having these communication skills to talk to your colleagues and ask them if they have any experience with it, right? If their personal experience, if everything that they know and everything that they've done includes this specific problem. So your own personal experience, your coworkers' personal experience, information resources, right? There are user manuals, there's Google, right? Like one of the biggest things that we do nowadays in order to try to find out a problem is, while we personally might not have a problem in our personal experience, and our immediate colleagues might not have that problem as a part of their personal experience, it's to a high degree of likelihood that somebody, somewhere in this entire world, has encountered this problem at least once. Right? Very rarely are we encountering completely unique problems that nobody in the world has ever experienced before. And so with this ability to utilize outside information resources, things like Google, right? Like, it seems kind of counterintuitive for an instructor, a teacher, to be saying, well, if you don't know the answer, you can Google it. But being able to do this sort of information searching and find people in the world that have had these problems so that you can use their experience to enhance yours is critical in this line of work, right? In information technology, in computer support. So being able to utilize these information resources to your best ability. And so we have two sets of questions here about troubleshooting. Because when we think about a process, oftentimes we like to silo it. We like to make it one particular thing. And when we're examining troubleshooting, we have the question of, well, is troubleshooting a step-by-step process or an iterative process? Is it something that we can follow from beginning to end? Or is it something that we might have to do over and over and over again to find out a solution? And the answer to that question of whether troubleshooting is a step-by-step process or an iterative process is yes. Right? Troubleshooting in the way that we experience is both a step-by-step process and an iterative process. Right? Like we have this defined process that takes us from beginning to end of working out a hypothesis. Right? We'll see this in just a couple minutes. Like when we're approaching a problem, we should be approaching it from this mindset of like the scientific method, where we're developing a hypothesis based on information that is known to us, and we take and we test that hypothesis and see if we can get a conclusion, right? So in that sort of way, it is a step-by-step process. But when that conclusion doesn't pan out, or if that conclusion doesn't solve the problem, then we have to iterate and try again and come up with a new hypothesis and follow that hypothesis to its conclusion. So when we're looking at a step-by-step process versus an iterative process, it's really both. And when we have this idea here of, well, is troubleshooting a scientific process or a creative process, right? And I just mentioned the scientific method, right? And to some degree, like, yes, right? Like, there's a lot of heavily scientific reasoning that's rooted in the troubleshooting process, but it also is a creative process, right? Because certain solutions that you try to implement aren't necessarily going to work in every environment. You're not always going to have the right part, or you're not always going to have the right thing that you need to maybe be able to work things out. You know, for example, if you're setting up like a data center, or you're setting up a server room, would be a better way to put it in this sense, because a data center is more planned out. Let's say you're setting up a server room. Well, you're restricted by that physical location. You're restricted by that space. So if some things that are in proximity to one another, you know, are generating too much heat, and so they're causing these issues, you have to come up with, in that case, a creative solution to that problem, because you are bound by the constraints of that situation, right? It's from our constraints where creativity is required. You know, if we were in a fantasy world where we had unlimited resources and unlimited space, and we could just kind of do whatever we wanted to do or whatever we needed to do, we could treat everything like a completely scientific process. But since we're not in that fantasy world, since we do have limitations and constraints placed on us, sometimes we have to get creative. So again, the answer to this question of whether troubleshooting is a scientific or creative process is yes. And so let's look at the idea here just for a brief second. We've already kind of touched on a lot of this, so we'll just kind of flow right through this idea here of an iterative process. When we're talking about an iterative process in this regard, we're talking about a repetitive process. So we have that sort of idea of, you know, taking that scientific method and looping it. Right? So we have this singular process where we have these steps of how we determine a problem, how we test a problem, how we implement a solution for a problem. And then when that solution doesn't pan out, what do we do from there? Right? So when we're looking at an iterative process, we really see something that requires flexible thinking. It requires you to be creative to some degree. Right? Because in that sort of way, you know, it's kind of like some of the stuff we talked about a few weeks ago, right? When we were talking about how we are communicating with our clients, our users. Right? We talked about one of the barriers of communication being coming into a problem with a preconceived notion of what the problem is and what the solution to that problem will be. And I think we sort of get caught up in that just in general, right? Like we think we have an understanding of a problem. We try to implement a standard solution for that problem. And then when that solution doesn't work, we kind of malfunction, right? Like it sets off this kind of 404 error, like brain not found there. And we sort of melt down to a degree. Because obviously, like when you have that preconceived notion, you think you're right. So you think, well, when I do this and this, everything will be working again and everything will be fine. But if you haven't considered any alternate routes, if you haven't considered a repetitive process, if you haven't considered, well, what happens if this doesn't work? What should I do next? Then you're stymied. You are in the mire, right? Knee deep in it. And that's a problem, right? Because then you're kind of stuck in the mud. And you're like, where do I go from here? What do I do next? What's going on? It's hard. Right? So we want to take several paths, several approaches to a problem until we find the solution. We're going to repeat this process in a loop until we get that fruitful path, until we get that path that solves the problem. And it's methodical, right? We're not talking about a hit and miss or trial and error here. We're not talking about just throwing solutions at a problem and seeing what sticks, right? We're talking about thinking through a problem, determining a hypothesis, testing that hypothesis, implementing a solution, utilizing a scientific method, right? And so we can see here sequential versus iterative problem solving. And we can see between our two pathways here, this is the difference. Right on the left here, we have our sequential. It just goes from beginning to end. On our right, we have our iterative. But our sequential implies an end, right? It implies that when we get to analyze results after we test that hypothesis, that it's over, that it's fixed, that it works. Sometimes that's true. Sometimes it isn't. More often than not, it isn't, right? More often than not, your first idea for a solution is not going to work how you want it to work. And so let's look at the process here and break it down a little bit more as we're kind of talking about it, right? And we can see that sort of scientific method kind of jump out at us here. Right, our first step, whether it's iterative or it's sequential, is to collect information and clarify a problem. Right, so this is that kind of stuff that we were talking about a couple weeks ago when we were talking about listening to our clients, listening to our users, getting this information from our users about what they perceive the problem to be. And we said that, one of the things that we have to do there is we have to sort of act like an interpreter. We have to act like an individual who is able to translate the language from user language, client language, to tech speak. Right, so we do that, and we just do some baseline testing, and we try to see, what's happening, right? We try to replicate the problem. We try to see what's happening and clarify the problem so we understand what the baseline problem is, right? That's the big first thing here, regardless of which type of process we're using, whether it's iterative or whatever. The first big thing is to understand the problem. Then we consider, well, what's causing this problem? What are the explanations for this? And we'll talk about a little method for approaching problem solving, considering these alternative explanations a little bit later. Something that I like to do. And then from there, we're going to formulate the hypothesis. We'll say, well, it could be this, it could be this, it could be this, it could be this, right? We create a checklist. Boom, 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 boom. And then from there, we say, well, the most likely problem is this. So I think, if we change this, then we should see this problem go away. So then we test that hypothesis. And we analyze the results. Now, sometimes when we analyze the results and our problem isn't solved, it's the same, right? It's in that same problem state as it was before you tried to implement any sort of solution at all. But sometimes when you implement a solution, things change a little bit. And when things change a little bit, you can't just necessarily jump back into that list of all the alternative explanations that you possibly could have had. You have to reconsider and collect more information to try to clarify the problem again, because now you have new information. Right? New information goes into clarifying the problem. So, I mean, think about it this way, right? Like, you've got a network adapter, say, and the network adapter, you know, you're not getting connection. You're not getting a network connection to a computer through an onboard network adapter. And so maybe you think, well, the network adapter is bad. So you put in a new NIC. And you test it again. And the new network adapter, maybe it's fading in and out, dropping connection every few minutes. Right, so by changing the network adapter, we maybe solved one problem, maybe we didn't. Right, maybe we just clarified the problem. You know, maybe it just needed to be reseated. And so when you put the new one in, you reseated it. And it showed that there was a bigger problem at hand here. So we have to get more information now and see what's going on there, right? So problems can change. Problems can morph and take on new life as you're trying to solve them. But whenever we're thinking about problem solving, essentially we're thinking about a process that takes us from our current state to our goal state. Right, and this will be a drawing that you see me do a lot over the remainder of the course. But essentially we have a chasm, right, between our problem state and our goal state. So we had our problem and our goal. We have where we are, which is that problem state, versus where we want to be, which is that goal state or the desired state. And when we're thinking about solving the problems and we're thinking about bridging this gap and trying to get someone from the problem state to the goal state, we've got multiple pathways that we can utilize to cross this chasm, to cross this gap, right? Like we might just be able to build a bridge. We might have some water down here, and we can take up a little boat. We might be able to fly in a plane. Across the chasm. Right? There are different ways to solve a problem. There are different ways to get from our problem state to our goal state. But the objective then becomes to try to solve a problem in a manner that is quick, accurate, effective, and efficient. There are those two E words again, right? Like we talked about those two E words last week, efficient and effective. You know, we said when we were talking about efficiency and effectiveness, we are talking about doing things right and doing the right things. Yes, which we talked about last week are, two entirely separate concepts. So we need to do things with speed. We need to do things accurately, we need to do things right, and we need to do the right things. And when we're talking about accuracy here, we're talking about precision, right? We want to try to pinpoint our problems, and we want to try to work on things from that perspective. So as we're approaching problem-solving strategies, there's a lot of different things that we can do just by default. Like, there are these standard sort of problems that we face all the time. And we can approach them with a certain set of strategies or a certain set of ideas for solution. We can look for a simple, obvious solution. Right? If it's something that you've seen a million times, right? Oh, my computer won't power on. Is it plugged in? Right? That's why we get those types of questions asked to us by tech support agents. Because that's the simple, obvious solution, right? Like we talk, like you hear people talk about Occam's razor. Right? We want to kind of shave away all of the nonsense, so we're just left with what should be simple, what should be obvious. The most obvious solution is usually the correct one. So if you've ever gotten frustrated with those kind of questions, that's why. It's the obvious solution. It's the thing that happens more times than not. And a lot of times it's a thing, right? Attempt to replicate the problem. This is a big one for us. Yes, like one of the things that we want to do is we want to be able to try to replicate the problem. And I want to spend some more time on attempting to replicate the problem because it is so important to us. So I'm going to put a pin in this one and circle back around to it in just a moment. Another one is to examine the configuration. How are things currently set up? Did some configuration settings get changed? Did maybe a software update cause some issues? Could just tweaking some settings fix the problem, right? So this happens a lot, right? We want to examine the configuration, initiate a root cause analysis. This is another one that I want to spend some time with. Is this idea of a root cause analysis. Because this one, especially in enterprise environments, data centers, and things of that nature, is a critical problem-solving strategy to do this root cause analysis. So I want to put a pin in that one and come back around to it and talk more about it. Viewing a system as a group of subsystems, essentially what we're talking about doing there is breaking down a problem. Right? If we're missing like if our network connection isn't working, right? We don't want to look at it holistically as a network that has all of our networking equipment on it, right? We want to look at it as the different nodes of the network. There's a router and there's a switch and there's, several end user devices and there's these cables, right? Like, it's not just one big system. There's a bunch of little things that are on this system, and any number of these little things could be causing that big issue. Right? So we take a problem and we break it down into its parts. We break it down into its subsystems. Right? That's something that we talk about in programming a lot, too, when we talk about, like binary sorts and things of that nature. Like when we break apart a problem into different paths. When we are trying to solve that problem in programming, we can take and memoize subtrees of a binary tree, and that way we can kind of solve for the subtrees, which will help us solve for the bigger tree, right? Like that's exactly, like if you're a programmer or if you had experience programming, that should kind of put some stuff into perspective here. But it's this idea of using, just kind of breaking down a problem into its parts, right? Using a module replacement strategy, just if it breaks, switch it out, right? That's one of the things that we do a lot. Like we say, well, we'll just start replacing parts, or we'll just start replacing equipment. So if something on this line is bad, we'll just start replacing things and testing, and then we'll figure out which one is good and which one is bad. A hypothesis testing approach, that's kind of what we've been looking at so far in the discussion, where we're following that scientific method through that iterative process. That's going to be something that you do, for basically every problem. And then just restoring to a base configuration, going back to those system defaults. So let's look at those two that I wanted to look at in more depth. The ability to replicate a problem and initiating a root cause analysis. So in attempting to replicate a problem, this is one of the most important things that we should try to do. And it's oftentimes one of the first things that we do when we're trying to approach this idea of discovery and trying to figure out a problem and solve a problem. Because we want to see if the problem persists, right? Or we can see the problem in action. Is this a big problem? Or is this a small problem? And trying to replicate the problem would give us that answer. When we think about replication in that sort of way, we're trying to repeat a problem in the same environment or in a different situation or environment. Right? We want to kind of test it in both. Right? Because if we're in the same environment and we test it and we can replicate the problem, then we know that that is a problem at least on that system. But if we're able to get on a different environment and replicate the problem there, that means the problem is even larger. Right? Like if we get on a specific system and there's some kind of software error or something that's not happening correctly with that piece of software, and then we get on another system and that piece of software works just fine, it could be some kind of configuration error, some kind of hardware or software configuration error on that particular system that's causing that issue. But if we get the same error in both environments and the environments are different, that points to a potential issue with the software itself. So we can see that the problem might just be a little bigger than what we could isolate on that user's machine. So we want to try to take our problem and move it to a different computer or move it to another user. Right? If we're having network issues, we want to try to take another computer, plug it in that particular network drop, or take that computer that's having the issues and move it to another network drop. Because that could point to issues with the drop or nodes immediately behind the drop instead of issues with the computer. And you could sit and you could try to fix the computer all day, but if the problem is behind, you would never figure that out and it would never work. Right? So you're trying to replicate the problem on the same environment and on different environments. Another reason why this is great for us is it just helps us see the problem. Right? Like if we can replicate the problem on the same environment, then we've seen the problem. It's one thing to kind of say, to tell a user, well, tell me about your problem. What's going on here? How's that going? And trying to gain an understanding from it. But there's an entirely different thing here to talk about actually seeing the problem in action and being able to put hands onto it. I mean, that way you can also better translate your user. right? And you can take that user speak, that client speak, and translate it into tech better if you can see the problem firsthand and get your hands on it and actually cause the problem. So attempting to replicate the problem is one of the things that we do a lot. Right? Like when I get contacted by students who are having an issue with Blackboard or who are having an issue with whatever kind of service here at the college, one of the things that I'll try is, I'll try to replicate it and see if it'll happen on my end. If it will happen on my end and I can determine that it's something that I can fix, then I'll fix it. If I can't get it to replicate on my end, I have to figure that it's probably something on your end, and you should probably go to the help desk and get that computer training and support there. So this attempt to replicate the problem can prove incredibly valuable to us. We also have this root cause analysis. One of the things that I think is especially important is trying to figure out why. Right? So that's one of the reasons why I like to approach this idea of a root cause analysis and talk about this root cause analysis. Is this idea of why. Like, we can face a problem and we can put a Band-Aid on it, and then in a couple weeks, a couple months, it becomes a problem again because we just kind of fixed something cosmetically and we didn't fix the root of the problem. We want to look beyond the symptoms that are kind of visible to us and look at the problem in a larger spectrum to try to figure out what could be causing that problem. And this, again, is an iterative process, and we're trying to figure out why. Yes, and when we're doing this, it could be just as simple as why. Well, it is just this one particular thing. That's the only thing, and we're done. But I like to think about it in larger issues. Right? Like, let's say a particular server in your server room's gone bad. The top one on a rack. You go and you replace the hardware and you get it working again. It seems to be some sort of electrical issue. And it works again. And then a couple weeks, a couple months later, it goes bad again. And you're starting to be like, well, what's going on here? Well, you could just replace it again. Chalk it up to bad hardware, faulty hardware. But you should probably be finding out why. Maybe if you look into it, you see, oh, there's water collecting. We're getting some condensation collecting on this duct in the ceiling, and it's dripping water down, and it's dripping water down into the ventilation of the rack, and it's getting on the internals, and it's causing a short. So from there, I need to say, well, what's causing this electrical issue? Well, it turns out it's this water that's dripping down. Well, what's causing that water to drip down? What's causing that thing to happen? Maybe I need to replace some kind of element in my climate control system. Maybe I need to change the configuration of my climate control system. Maybe I need to change the orientation of my data center. Trying to find that root cause analysis. And one of the big things here that you should do, that most people don't want to do because it seems busy, right, is to do these steps in writing. Identify in writing what the problem is, and then describe in writing why the problem occurs. And then in writing, you're following that problem up the ladder until you find its root. You're repeating all of these steps until you identify the root cause of the problem. Because then not only have you figured out the problem, but you've also created solid documentation. So in case maybe this problem ever happens again, maybe this particular part goes bad again or whatever, and you start seeing these things again, you can jump in there and you can say, oh, I have documentation for this. I can follow this back and I can look at these different steps and I can go from there. Right? Because you might forget. You might forget part of it, especially when you're looking at like a 6, 7, 8 step process of trying to find the root cause of a problem. You could easily forget step 4. So trying out a root cause analysis and attempting these things so you could try to get back to that baseline of understanding where your problem is and how it needs to be fixed is important. I've got a lot more things that I could talk about, but I think we could probably wrap this one up just a little bit early. Let me see here. What's a good thing that we need to cover here? Let's talk really quickly about the idea of scripts and checklists. Why we would use those as a part of our problem-solving process. Right? Because you've probably called tech support at some point, gotten a level 1 support technician, and they've read from a script to you regarding the problem that you're trying to solve. Right? And what we see here really with these scripts is the result of years of hundreds of instances of encountering these problems. And so these scripts are based on data that's been collected over the years. We've done these root cause analyses for problems. We've done these iterative problem solving processes in the past. We've got a bunch of tier 1 support agents that, they might sort of be a revolving door, flex in and out. We have to hire new people every so many months or so just because they're on to bigger and better things. And so we need these scripts to sort of bolster that knowledge base. And so it makes a lot of sense to use a script. It gives you these questions to ask because these questions are built from past experience and how to follow up to certain responses. And it starts you in places that seem obvious to us since, we're IT people and we know what we're doing. Right? I was working on an issue that was a larger issue. It turned out that needed, there's a cable from the outside. One of the lines to the house was bad, and they had to come out and replace it. But I was fixing an issue with a relative's internet, and so we called the ISP's tech support line, and they had to go through their show. Now, they asked me to reboot the modem. And of course I had already tried that because I know what to do, right? I'm an IT person. I'm kind of like, I've done that, just trace the line, see where the node stops, because you have the ability to do that. You have the op. But they have me reboot the modem because that's a problem they run into frequently. And it's one of the first things that's on their script. Just reboot it. Turn it off and turn it back on again. And they don't do that just because it's an easy solution. They do that because it's an easy solution that a lot of people don't do. You know, we kind of have to take ourselves out of our IT computer person mindset for a minute and think about the average user or the regular user, right? You know, we go back to like the user classification system that we talked about right off the jump there in Module 1. Right, the majority of the user base is going to be that novice user. So you have to approach things from that perspective. You have to start at that point. So, you know, oftentimes we see these scripts, they're organized as some kind of flowchart or some kind of decision tree based on questions and responses and things of that nature. We put it in a logical sequence. So we get that problem-solving process here, right? We basically just take the problem-solving processes that we had done previously and we put them into a script. And so we're solving the most common paths to a problem, right? And that's what Tier 1's going to need to do. And they're going to need to, use these scripts to triage the problem, figure out what's going on. Then they can go through some of the basics in the script to see if that solves it. Oftentimes it does. Sometimes it doesn't, and then it can be escalated to the next tier. So that's pretty important. Let's talk about knowledge bases here and just how important it is that we take advantage of knowledge bases. Like, as I mentioned earlier, like our personal experience and the personal experience of our colleagues does not encompass all of the world's information. So it's important to have a knowledge base, a collection of organized information that we can use as a resource in problem solving. A lot of the help desk software that you looked at as your lab last week has a knowledge base built into it, right? So as you're solving a problem, you document solving that problem. So future people in your company, maybe ones that are there after you're long gone and moved on to something bigger and better, are able to use what you learned from a problem to solve new problems. But this also includes internet articles, tech manuals, pointers to information, just finding people solving problems online, like on Stack Exchange. Or just people asking questions just wherever, right? Reddit and, Reddits and all this sort of stuff. All of these knowledge bases provide us with some things that we can learn to help us solve our problems. Because while we might know a lot, it's important to reinforce this. While we might know a lot, while our colleagues might know a lot, the collective experiences of ourselves and our colleagues is not the entire knowledge of the world. We shouldn't. Here's another important factor here. We shouldn't try to treat ourselves like it should be. I think that's pretty important. We shouldn't try to treat ourselves like we should know every single thing in the world. All right, like that's just going to lead us to some mental health problems, right? We need to take advantage of our resources, of our knowledge bases when we have them. And if we don't know the solution of a problem, that's okay. I think it's more important for you to know how to figure out the solution of a problem using a knowledge base, using trial and error, not trial and error, but using an iterative process, right? We said a good iterative process is not trial and error. It's determining a problem based on information, based on facts. And solving that trial and error is just guessing and checking, right? We don't do that. We solve a problem based on facts. Using a good problem-solving process to try to figure out problems, and using knowledge bases to try to figure out problems, instead of getting down on yourself and getting mad at yourself or trying to study a whole bunch for solutions that you might not ever encounter because you didn't know the answer to a particular problem. That's not necessary, right? We'll wrap this up with this one. The characteristics of successful troubleshooters. Because all of our troubleshooters, everybody who has kind of worked in this problem-solving process, they exhibit a few characteristics here. And I think as you're approaching the process, if you're approaching it with this mindset, then you're going to be A-okay, right? And the first one is to exercise patience and persistence. Patience with the, both of these kind of work with the understanding that it could be an iterative process. This could be a rabbit that we're chasing for a while to try to figure out what's going on. Because not everything is as clear as it might seem up front. Right, so we might be chasing this process down. We might have to go through several iterations of our sort of scientific method process. So we can't get discouraged. We can't give up. We can't get impatient. We have to work with the understanding that if we keep following the process, if we trust the process, if you will, then eventually we'll figure out the problem. Sometimes it takes longer than others. Another thing is to enjoy the problem-solving process. If you have fun with it, if you like trying to figure things out, if you like trying to learn new things and approach new problems, you're going to be better at doing it. Right? Like that seems like a no-brainer, right? Like if you like anything that you do, you're probably going to be better at doing it just because you like it. You have a sort of passion for it, a desire to do it. Another is that you enjoy working with people, right? Involving your colleagues, using that collective experience, adding everything that they know and everything that they've done to your experience of everything that you know and everything that you've done. Having that collective experience is incredibly useful to the problem-solving process. So being able to enjoy working with people and enjoy them sharing with you their experience and you sharing with them your experience, that's only going to serve to benefit you. And finally, look for learning opportunities. Right? We're in an industry, information technology, that changes constantly. Every 6 months at the very least, we're being faced with a new set of problems. Right? So in that sort of way, we have to become lifelong learners, and we have to enjoy learning, and we have to always consider the fact that there's something new that's probably going to come up. And that doesn't necessarily mean that we have to stay ahead of everything and try to study everything as it comes out and get on top of everything. A basic awareness, knowing that maybe when your company is introducing something new, you might want to study that specific thing so you can prepare yourself. And knowing how to use your resources to figure out and learn about new problems as they arise. And one of the tips that we have here is to subscribe to an online trade publication that offers a broad perspective on trends in the computer industry, just so you can kind of have an understanding of where things are going. Right? We're not talking about specific issues here. We're just talking about an awareness of where things are going. So that if in 3 months' time, in 6 months' time, a year, 2 years, 5 years' time, you start seeing these things pop up, you're ready. And so that's essentially what I want to talk about today. I think we're at the end. We're a little short of our hour today, not too much. But I think we've done enough to where we can go ahead and wrap it up. Your Module 4 assignments are due on Sunday. So please make sure you have those due there. I will send you the weekend reminder, as I usually do, toward the end of the week. I'll be hanging out in the chat just in case anybody's here with me live and has any questions for just a couple minutes here. If you're watching the recording here and you have questions, please let me know. Send me an email, send me a Teams message, and I will help you the best way that I can. But that's all that I have for you for this week. Thank you for watching, and we'll see you next time.